Hello everyone, I am Kano Sasaki in Kogakuin University in Japan. Our title is TCP BBR Performance Improvement on the Network with Increasing RTT. This is outline. First is background. Performance fairness among modern TCPs is an important issue. Obtained throughput depends on TCP algorithms of OSs. TCP BBR was proposed in 2016, and discussion of fairness between this and other TCPs is important. Next is related work. This is cubic TCP. This is a famous loss-based modern TCP. This is used in the Linux kernel. This figure illustrates the cubic TCP behavior. Cubic TCP increases its window size until it detects a packet loss. Namely, it usually causes an increase in RTT. TCP BBR is a congestion control algorithm proposed by Caldwell et al. In 2016. TCP BBR estimates the physical propagation delay, which is called RTprop, and the bottleneck link bandwidth, which is called btlbw. TCP BBR calculates BDP using RTprop and bottleneck bandwidth, and then controls its congestion window size to be close to the calculated BDP. BDP is bandwidth D product. Next is basic evaluation. We measured the throughput, congestion window size, bottleneck bandwidth, RTprop, and RTT of TCP BBR and cubic TCP when they communicate concurrently. This is the experimental network. Sender 1 uses TCP BBR. Sender 2 uses cubic TCP. They send packets concurrently using IPv3. This is the experimental setup. Time to measure is 40 seconds. The maximum window size is 2000 megabytes. Bottleneck bandwidth is 1 Gbps. Number of connections are as follows. TCP BBR 1 connection, cubic TCP 1 connection. This is the result of throughput. This figure implies the unfairness of throughputs. The BBR's throughput significantly dropped from the start to 30 seconds. Cubic TCP consumed almost all the bandwidth, and the BBR throughput was about 10.5 Mbps. The ratio of the throughput of cubic TCP divided by that of BBR was about 88. These are the results of congestion window and bottleneck bandwidth. This figure also implies a similar trend. The cubic TCP's congestion window size started increasing just after the connection establishment. On the contrary, TCP BBR's size started much later. Bottleneck bandwidth was about 1 Gbps at the start of the communication, and remarkably decreased from this value to a very small value, which is around 8 Mbps. This is the results of RTT and RTprop. The RTT was about 20 milliseconds in the first 10 seconds, and RTprop was only 0.4 milliseconds. Unfortunately, this underestimation was kept until the next update of RTprop. The ratio of the RTT divided by the RTprop was more than 40. This severely underestimated RTprop resulted in too small the congestion window size and a severely low obtained throughput. This is a summary of the basic evaluation. Bottleneck bandwidth estimation. Bottleneck bandwidth is underestimated with increasing RTT. RTprop estimation. RTT and RTprop become largely different with increasing RTT. This underestimated RTprop results in too small the congestion window size. There are two conditions for updating RTprop. The first is this point. TCP BBR updates its RTprop 10 seconds after the last update. This is called expire. TCP BBR stops sending packets in a short time and drains packets from the queue. This expires decreases the throughput in the short time. The second is this point. TCP BBR updates its RTprop when it detects the RTT less than the current RTprop. This is issue of RTprop with increasing RTT. If RTT continues to increase, RTT and RTprop must become different. In this case, TCP BBR doesn't update its RTprop for 10 seconds. This difference causes the performance decline. The suitable congestion window size is bandwidth times RTT. TCP BBR's congestion window size is bandwidth times RTprop. If RTprop is largely less than RTT, its performance becomes very low. Next is the proposed method. We propose to modify TCP BBR for relieving this severe throughput decline. The modified TCP BBR updates its RTprop by executing expire. Also when it detects the following two conditions are satisfied. One is the measured RTT divided by RTprop is greater than ratio threshold. The other is the measured RTT is greater than RTT threshold. For avoiding frequent expiring caused by a small RTT, the proposed method does not conduct expire if the RTT is smaller than the threshold RTTTH. Measured RTT divided by RTprop is 6. In this case, expire is not executed. Measured RTT divided by RTprop is 1.5. In this case, expire is executed. Next is evaluation. We measured the throughput, congestion window size, bottleneck bandwidth, RTprop, and RTT of the modified TCP BBR and cubic TCP when they communicate concurrently. TCP of the sender 1 is the modified TCP BBR. Ratio threshold is 2.5. RTT threshold is 5 milliseconds. The other settings are the same. These are results of throughput. Left one is the result of the original TCP BBR. Right one is the result of the modified TCP BBR. We can see that the performance drop was substantially relieved. In particular, the unfairness caused by the throughput drop of TCP BBR at the start was mitigated. These are congestion window sizes. We can see that the congestion window size of the modified TCP BBR increased earlier and more aggressively than that of the original TCP BBR. These are bottleneck bandwidths. The bottleneck bandwidth drop of the original TCP BBR was significantly relieved by the modified TCP BBR. These are RTT and RTprop. The modified TCP BBR reduced the difference between RTT and RTprop. This is a summary. The modified TCP BBR made the ratio between RTprop and RTT smaller. As a result, the performance of TCP BBR improved and the fairness became better. Next is conclusion. We evaluated the performance fairness between TCP BBR and cubic TCP. We showed that TCP BBR performance and performance fairness were low because of the underestimation of RTprop. Proposed method and evaluation. We propose a method for relieving this low performance by updating its RTprop, also when the difference between RTprop and RTT is large. Future work. We plan to discuss a method for automatically tuning the parameters of the proposed method, especially RTT threshold. Thank you for your attention.